Okay, so welcome everyone to this talk by Sanjay Krishnan. Over to you, Sanjay. And it'd be great if you could, get a little deeper into your background and share your experiences before you actually get started with the talk. Thank you.
Sounds good. Thank you. Thank you for having me. Thank you, Raghu, for the invite. And, I also took a tour earlier today at the Art Garage. Really nice facilities. I haven't seen all of ARTPARK yet, but what I see here is like pretty impressive in itself. And thanks for all of you for showing up. So we'll keep this pretty informal. Feel free to interrupt me at any point if you have any questions. Just raise your hand. I'll try to answer as we go along. I'll repeat my questions so that I'll repeat your questions so that the people people viewing this later can also understand and hear. So a little bit more about my background. So Raghu gave a good summary, but I have been in Silicon Valley for the last 25 plus years. I graduated from here. I've been working in different tech companies. He mentioned Google. That was one of them. One of the projects I worked on at Google was this thing called Cardboard. I don't know, this was like maybe 10 years ago now. Some of you may have heard of it. There was a device which was basically take your Android phone, put it into this piece of cardboard, fold it, and it gives you a 3D VR experience, right? It's like cheap $5 VR goggles. And the idea was competing with Facebook or Meta at that time, which had just bought Oculus for several $1 billion, and VR was going to be the next big thing. And so what was interesting was the smartphone had enough of the sensors and compute to be able to do real-time 3D positioning, right? And which is what you really need to have a real immersive experience. Now that same thing is also fundamental, like the technologies there, common filters and others are used in robotics, used in autonomous driving, used in a whole bunch of other space applications. Lots of startups here with drones and all that also are using that. You guys probably are already familiar with it. I see a ROSCON t-shirt. I couldn't make it to ROSCON here, but a lot of ROS applications are basically feeding the 3D and robotics and self-driving and all of these things. Now today in this talk, I'm going to focus on a few mostly like commercial aspects of this, especially with startups when you're trying to go into different industries. What are the various do's and don'ts, some of the things that you have to think about, because when you want to get commercial, there's a whole bunch of other things that come into play, especially when it comes to autonomous driving. This is, I've learned over the years some of the things that you get faced with in terms of safety and regulation and all these kind of things. Sometimes less so in robotics, but we'll jump into that. The idea here is some of the lessons learned from the autonomous driving side, how we can apply that to robotics, what in the future, if you're working for startups or even big companies for that matter, you have to watch out for, how you navigate some of these things, how you overcome these. Hopefully lessons that will be useful for you as you go along in your journey. Any questions so far? All right. I'm going to skip over the agenda. We'll go over this as we go along. One of the things that we get asked a lot when it comes to self-driving cars is, is it safe? How safe is it, right? And the question of safety is usually answered with statistics, and this is a slide that I actually took from one of the talks I gave at Stanford University in their business school, where we were trying to establish, in a class that's called Data and Decisions, about what makes it safe and how can you prove that it's safe, right? And so there's statistics is well established in this, and human beings, if you take one of these three columns, let's focus on the rightmost column over there. When you have a human driver, you do something like 190 crashes per 100 million miles, okay? So does that mean that you need to drive 100 million miles in a car to prove that it's equivalent? No, you don't have to actually drive 100 million miles. You may have to drive a little bit less to be able to prove that, statistically speaking, that your car is as safe as a human. But the more miles you drive, the higher the confidence level becomes that you actually have enough data to prove that you are, what you claim to be, right? So that's what this table is trying to prove or show here, is that, let's say, the number of miles, let's take the top row, for example, okay? If you want to prove with a 95% confidence level that your self-driving car, which is what this exercise is all about, right, is at least as safe as a human. From the crash's point of view, you have to be able to drive 1.6 million miles without a crash, right, in order to be able to show that with that level of accuracy. Now, humans also, there are 3 different columns here saying, well, human crashes per miles, the human also have injuries, and there's also fatalities. Fatalities are fewer than in number and so on. You can choose any of these columns to do the same exercise, right? The idea is, of course, that these 3 columns are correlated. The more crashes you have, the more injuries you'll have, more fatalities you have. So pick one, and you can use data to actually show that. Now, okay, now that's good. Now we know that there's 1.6 million miles you need to drive. Well, how many? So all these companies that are doing self-driving cars, right? They've driven millions of miles in simulation, but that doesn't count, all right? When you want to prove to the authorities that you're actually safe, you need to actually show them real-world miles data, and that's what's been happening in the U.S., right? In California specifically, there's the body's called the Department of Motor Vehicles, who has given the authorization for these select companies to actually drive driverless cars on the road, operate them in whatever business they want to, as a taxi service or whatever, right? But they have to collect the data, and they have to report back to the DMV every year how many times was there a disengagement. So this is the kind of report that they have to file. This I have consolidated across all of these companies. They have to file a report that says how many miles they drove and how many disengagements they have. Disengagement is basically when the safety driver takes over because the car did something unacceptable. Maybe it was about to crash, maybe it was about to hit somebody, maybe something was going to happen. So we don't know that a disengagement means that there's a crash or an accident, but it means that it could be, right? So then that's what the report that they're supposed to file. Now, Waymo is a subsidiary of Google's Alphabet, and they're the leaders in terms of the number of miles they've actually driven, right? They've actually reported in 2023 that there were 212 disengagements, which kind of comes to, miles per disengagement. That last column is not something they have to report. It's just something that I calculated. So Tesla, that's a good question. The question is, how come there's no Tesla on this, right? Now, Tesla is actually not deploying a driverless solution, all right? Tesla claims this feature called FSD, right? Full self-driving, and they're putting it out there. You can download and you can drive a Tesla on the thing. But technically, if you read the fine print on that, it says there's a human, you as the driver your hands have to be on the wheel, and you should be able to take over if the system is not performing. So it's a driving assistance system, right? Despite what their marketing says, that's what it really is. So they don't have to file this, and so they don't appear on this list.
But truly autonomous.
No, not in that sense. So this only applies to those companies that have a truly autonomous permit, which is different from what Tesla has, right? So there's some interesting things here. First of all, you can see that Waymo has actually driven more than 3 million miles, right? So in some sense, they have enough data to actually prove a few things statistically, and they can actually show it. Now, they had 212 disengagements. We saw from the previous page that, you need to be able to drive something like 1.6 million miles without a crash to be able to prove you're in the zone of a human. So you can say that, hey, you know what? None of these is really close to being at a human level accuracy. But this data is all self-reported, and there's no consistent way in which how you measure a disengagement. Secondly, the disengagement also doesn't necessarily mean there was going to be an accident. It could be so many causes. So this data is highly imperfect from that sense. But at least from one sense, we know that there are enough miles being driven for people to be able to say that, with confidence that we can do something or not, right? In terms of like the actual safety record. The reason I brought in all this was just because to give you an idea of what, at least from the automotive industry, how much scrutiny there is and how much people are paying attention from a regulatory point of view on what exactly we are doing. Now, some of these things are, the car industry is not super happy with this. Elon Musk has gone on record saying, this is kind of crazy, whether it's 99.999% reliable or a few more nines is just kind of getting nutty. The human standard is a low standard, and people are distracted, and And, his claim is Tesla is way safer than this, and he's probably true, right? But unfortunately, there's a public perception, and we need to also be able to prove for some level of public comfort that, hey, we have the data, we need to be able to prove it. Now, whether the car industry likes it or not is a different matter, right? And there's like something else going on there. There's also, by the way, in 2023, there was a different news report where somebody calculated, just based on Tesla's own marketing and their own comments, that there were 150 million quote-unquote full self-driving miles that Tesla reportedly has their customers, reportedly Tesla customers have driven with so many recorded fatalities that they've also published in some paper, which kind of implies that Tesla is actually not as safe as a human, with what Tesla has been putting out there in terms of a full self-driving. That could well be true. No, we don't know the claims on this. We don't know all the data, and they're not required to file all the reports just because this quote-unquote full self-driving system is not exactly one of those regulated driverless systems that are on the road. So the industry is a little bit all over the place on this, and Europe is a different story. China is a different story because each country has their own regulatory framework. Europe tends to be somewhat more conservative. They will try to establish the rules of the road before they start allowing people to do these things. The US is a little bit looser. Looser meaning like more relaxed in terms of like regulation. They'll let the companies do their thing, figure it out, have some accidents, and then the regulatory framework will come after that, right? That kind of thing happens a lot in the US. There's also competition between California and Nevada and others because the car companies know where to go to find the best regulation that they can find to move the technology along faster. So that's kind of what's going on here. But let me take a little bit of a detour into, what the actual challenge is, for example. But before we go into the computer vision side of things, any questions so far? All right, so, the question about India, no, I actually don't know. I have spoken to one of the Tata Group companies, right, that they are doing some R&D into driving assistance systems. I think driving assistance will come, if not already there, in terms of lane keeping and, warning systems if you are straying out of your lane type of thing. I think over time, all of these features will come. And it is same thing in the US too. They come in the form of driving assistance systems, and then eventually, I'm sure they'll get to full self-driving. The idea of the AI is, complexity is not an issue. The idea is that, at least nowadays, right? You throw data at this AI, it's going to learn. It doesn't matter if it's a confusing Indian road scenario, it doesn't matter. The AI should be able to figure all this out and do what a human would do. Now, is what a human would do, would we find that acceptable? That's a bigger challenge, right? This is what we're seeing in the US too, is that, people are still skeptical. So Waymo, which is the one that's actually operating a full self-driving service as of today in San Francisco, right, is actually losing money on that. And part of the problem is public acceptance, despite the fact that they have enough data to show, despite the fact that they have good record, it's not really commercially at scale yet. And we'll go into some of those reasons for that. So you can see, some of the breakthroughs in AI came from computer vision when they saw that, with ImageNet, AI was able to do better than human accuracy in identifying and classifying objects. The original data set for that was called ImageNet, where examples of this was like a chair, and AI was able to say, hey, that's a chair, and that's a table, and things like that. What they didn't have was chairs in like oddly placed positions, like these things on the right, which was there is another data set. It's called ObjectNet, right? And what they found was that if you compare AI or computer vision performance on ImageNet versus ObjectNet, right, where you have these like really weirdly placed objects that a human would figure out, it was actually the AI was actually finding it difficult. Right? And it was like 40 to 45% less in terms of accuracy. And that was one of the things, right? When we say AI is at human performance, yes, but in certain conditions where you can actually see things clearly like this, but in certain confusing conditions, AI was actually struggling. And that was part of the problem in self-driving, because a lot of the accidents are happening in these like weird corner cases where, you don't exactly know what the heck that thing is. Is it crossing the road? What is it? And then, you see something like that. Now, if the AI has to predict whether that thing is going to jump across the road or should we stop, I don't know. That's, the AI is not being trained on, monsters on the side of the road. So it's like super confusing. And this is the kind of thing where human would know right away. Yeah, I'm in, Disneyland, it's standing there, I'm going to go, right? But the AI is not, is first time it's seeing this, it doesn't know the context. It doesn't know that, hey, I'm in a theme park, this is perfectly acceptable. There's probably a human inside. He's probably not going to jump on the road. He's not a real, whatever. But I don't know what the AI has been trained on. If the AI has been trained on cartoons, maybe what this character does in the cartoon is what it's going to think of, right? So the prediction that AI is going to make, and that's the thing, is unusual situations like this is what causes most of the accident. And humans actually go through this a lot easier than what AI does, and which is sort of that ImageNet, ObjectNet problem I was talking about, right? And that's really the problem with self-driving. These corner cases that we think occur like 0.0001% of the time happen, let's say once in 1,000 miles, but that's like, once a month for the average driver. And you don't even think about it. Once a month, you find some odd situation that's never happened to you before, but you just keep on going, you figure it out and you keep on going. And that AI is going to trip up. It's going to have these disengagements if there's a safety driver. If you are the owner of the car, then you are the safety driver. You have to take over. And if there is no driver and the AI continues driving, it's going to make some decision. Once in a while, that's going to become a decision that leads to an accident, and that creates this whole problem. So this is one of the things that it makes the business case like really difficult, right? So this was one of the questions I used to ask when I was in teaching this class at Stanford. This is from Lyft, which it's like Uber, right? They had for a while an experiment where they had this self-driving option. From the app, you can either choose the normal option or the self-driving option, same in terms of like when you're going to get to your destination, and same price also. And so I would ask, how many people would take the self-driving option? Maybe I'll ask this question here, even though, it's not really an option here. Just, put yourself in that situation. Raise your hand if you would choose the self-driving in this, option where it's going to take the same time and the same cost. Nobody?
Are we in a lockdown?
In how
Are
to?
we in a lockdown? Normal?
No, in a normal situation. No, normal public.
Just for the novelty. I might come in if it's a short run.
Yeah. I don't know. Yeah.
But
Anything more? Yeah. This was kind of.
Across the 101 in the area, probably.
Yeah. Yeah, so this was kind of like, this was the normal response I would get, like one or two people would raise their hand, not everybody. So this was kind of one of the problems. And so if you're trying to do the business case, right, one of the most important thing is, what is the pricing you're going to offer? So Waymo, in their experiments in San Francisco, they're operating this as a service. The pricing is roughly the same as what Uber or Lyft would charge, right? So now you're actually competing against a driver with a similar price point. Then you need to have something really remarkable. Not just the novelty of the experience is not good enough, right? You need to be able to either get the person there safer, faster, better, something like that, or it's got to be significantly cheaper. And it's not that. And so this was kind of, I think, in my opinion, this is one of the problems they were running into in the business model. And the reason why they're still losing money in this today is because I think they are competing with the human driver. The original idea of AI was, hey, this thing can do human-like decisions with when you presented data, especially small decisions, quick decisions, simple decisions that the human brain does. We should be able to do it with AI. Sure, yeah, you can. Driving is sort of like a minimum wage job. So the idea was, hey, a driver we should be able to replace. The AI is able to do most of the decisions. That's mostly true. But turns out that even though it's a sort of a minimum wage job, the number of like different parts of your brain you're using it when you're driving is actually quite a bit more. The number of like contextual things you know about the road and the behavior and the people and the animals and whatever, right? Is there's so much of that background information the driver has that it's really not that simple to just put an AI there and ask it to drive. It's going to make quite a few mistakes. I mean, you're trying to make a business out of this. Pricing this in a is going to be super critical. I think eventually, yes, I think give it another 10 or 20 years. I think people will get over the novelty factor and the acceptance and all the regulatory, insurance, all of these aspects will also probably be settled, resolved through, claims and court cases and all those kinds of things. But it's going to take a long time to get there. right? People thought that this is going to happen very soon, and people are not saying that anymore. The last couple of years, most people in the tech side are saying, yeah, it's going to take another 10, 20 years. We don't know. Let's wait. Because until last 10 years or so, people were saying, self-driving is around the corner. Next 2 years, maybe we're going to have this like robo-taxi. Yeah, so now people are less bullish about that whole thing nowadays. And, trust in self-driving is, funny enough, not actually trending higher. It seems to be trending in the wrong direction recently. Another survey from, I think this was from the Automobile Association, if I'm right, where the bar that says afraid, which is like the red one, is actually going up over time, which is not what we expected. So there's a lot of funny things going on here that people are not expecting, which is part of the problem for self-driving, right? McKinsey had a report that said, any company that wants to commercialize this and and sustain competitive position is going to have to invest $70 billion over the course of the rest of the decade in this thing, which is playing out to be true. I think Waymo has already invested that much. Cruise, which is a subsidiary of GM, has also invested in the order of billions. Recently, they have scaled back some of these things because I think the appetite for sustaining that much is also gone down. And we'll see how long Waymo continues down that path. So in summary, I think, we're in this, what's called this, probably the trough of disillusionment phase in this whole cycle when it comes to self-driving. Where I think we're past the euphoria, but we're yet in this like final plateau of productivity. And I think this is a, as some people have said, maybe 30 to 50 year game. One of the reasons I think we should not be surprised is the lesson we learned from the elevator industry. Okay, the lift was invented in the 1890s or 1900s, and it had this lift man whose job was to push the button, close the door, and do all that kind of stuff, right? So the elevator was this mechanical thing that needed an operator, and it took about 50 years, in 1950, for people to get comfortable and eliminate that person and to get into this like driverless elevator and push the button and go themselves. So if it took 50 years to get that level of comfort, you can imagine it's not going to be that quick to get into a driverless car and just go, right? And there was lots of other things also came along the way, like for example, so in 1945 there was it was a unionized job, and there was this elevator operators union. They went on strike in the 1940s, and then that's when I think people finally said, maybe we don't need these guys. Let's just like get rid of them and push the button ourselves, right? So this kind of thing will also happen. There's like unions, bus drivers unions, and other things going on in San Francisco. They don't like this whole self-driving thing. They're trying to, kind of show that this is unsafe, and this can get in the way of ambulances and fire trucks and all this kind. So they're trying to point out those things because they are afraid of that. So I think this is the reason why, the business side of this technology is actually more a problem now than the technology itself, because you're coming across all of these things. So if you're doing robotics and stuff, keep this in mind that if you're going into an area which is safety critical, there's always going to be people who are going to ask you these kind of questions, like how do I know this is safe? I don't trust it. I don't believe it. If there's a failure or if there's a problem, fingers will be pointed to the technology before anything else, and they'll say, look, I told you this thing is dangerous. So keep all this in mind. Hopefully this is not a story that you'll have to face, but this is going to happen no matter what. And robotics is coming into the space where a lot of robotics, they want to do like not just in a cage or something, but robots in human environments where they're actually kind of collaborating with humans. And so you are going to have some cases where, robot hits a human hits a robot, who's to blame and stuff like that. So whenever you're using AI, in theory, this is the same even with AI predictions, even if it's a chat-based AI that's giving you prediction, it sends you down the wrong path and does something, then who's to blame, right? So AI in any space is going to face the same kind of issues. But if it's safety critical or mission critical in some other way, the bar becomes higher, and all of these questions are going to be asked. So be prepared to be able to answer all of these, or at least have a way to answer them in your mind, so that when you're not surprised when this thing comes along. All right, so that's kind of the first part of my presentation. Any questions so far? Yeah.
monster. You cannot basically utilize the abilities on what position he is or whatever. But basically, we don't really need authentication. Because we use VDAR kind of system, we face one another, then we access certain object and then how far it is and how, which type of object it is. So, why authentication was a problem in the beginning.
Okay. So I think the question you're asking is, we can detect an object accurately with a LiDAR, for example. Why do you need to know whether that's a monster or what is it, right?
Why do you can use like authentication?
So the reason why that the understanding the object is important is that you also want to be able to predict what the object will do in order to design your AI's response. Your AI is in charge of planning the trajectory of the car and driving, right? And so to be able to do that, you want to predict what that object will do. So to do that, just because your LiDAR may say it's a stationary object, but if you know that the object is likely to cross the road, then you have to drive accordingly. The way you know that is by understanding semantically what is it that object represents, what is its behavior, what do I know about that behavior. So that's the reason why most people, the driving software is interested to know what their object is and map it to what it knows about the behavior of that. So there are simpler systems, like you said, which are basically, they're called like collision avoidance systems. So whose job is simply that, if the object is moving and it's likely to come in your path, then hit the brake and stop. If the object is moving somewhere else or not moving, it's not going to be in your path, then carry on. So that is a simpler sort of system. It's like it's what's called level 2 systems, like a driving assistance or collision avoidance or those kind of things. It's not really an AI that is making decisions, and you can't ask that AI to make a decision to drive around and get you to your destination. This is just a much more basic level that you're talking about.
I think the early versions they were talking about caravans. What happened there and why that.
Right, yeah, okay. So the question is about caravan systems. So like a lead follower type system where there would be a lead vehicle who is human driven, and there's a convoy of vehicles whose job is very simple. They just have to follow the vehicle in front of them. That was, and so you can, automate, instead of 10 drivers, you need only one driver. The rest of them are driverless. And the job is simpler. You don't have to predict so much. It's much less safety critical. So what I have seen is those kind of systems are being used in mining and some places like that, but not on the public road. I think public road becomes more difficult, and they, even in those kind of situations, you need the safety certifications and all that, because you still have the case of somebody kind of coming in between these cars, and you can't guarantee the convoy. So,
But on the highways,
it's, in theory possible. Of recently, I have not seen that kind of thing. So they are doing highway trucking with autonomous systems, but one truck at a time seems to be the focus. Yeah, you're right.
the old days,
Yeah, I know. Yeah, this has been around for 15 years now. I've seen that a long time, even more than that. Yeah. There's been videos from the 1950s showing like General Motors saying, the future of this car is like, self-driving and all that. We've been talking about that for many years, but even caravan, I don't see that much nowadays at all.
I had a question.
Yeah.
Some of the statistics, to me at least, is a little misleading, right? Like because some of the statistics, at least in my head, it's a little misleading, okay? Because there is a diversity of human skill set. There are like really safe drivers who have never gotten in an accident in the 100 million miles, whereas you have like reckless drivers and they get into a lot more accidents. But on the other side, the software itself is a little homogeneous. It's a flavor that comes from Waymo or Apple or whatever that is. I'm wondering if folks have done any research on like a driver profile or a risk profile that you can load up front, because like I could say that you can go a little slow. If you find some novel scenes like this, stop, don't make decisions in a rush. Whereas someone would say that efficiency is all that is important and you need to load those kind of driver profiles, right? But it feels like all of us are getting the same software.
Yeah.
Does that make sense?
Yeah, no, I see what you're saying. The question is about, is there such a thing as different drivers and what is the target for a safe driver? No, I am not aware of what you're talking about, which is, are there different driver profiles and can we target different ones? And what is the statistics for safety? Like this average we're talking about, that's just an average human driver, which, maybe the target maybe should not be the average human driver, but actually a good human driver, which may be a different statistic for us to meet. And what is good also is like questionable, right? Is like, and there are maybe fast drivers who are actually good in terms of statistics, so that may be too. But no, I'm not aware of research on this. It'll be interesting to know that. But it's possible that in the driverless future, that's how brands will differentiate themselves. Like Toyota, their car may be about, safety, whereas your BMW, all of them driverless that you download, may be more of your fast, car or sporty driver profile or something. It could be. But those are the kind of business models that were being projected that we're going to have in the future with all these self-driving. Maybe you can download what you want for that day and say, hey, I want to drive fast today or something. And I don't know. But no, I don't think there's been any academic research for sure. I have not come across any. Okay. Let's go quickly to... So anyway, we talked about AI. I just want to say that, self-driving is not the only thing where AI is being used in the automotive industry. Even in driving, there's also lots of other things going on and AI is being used. Data analytics being used. There are different applications, fleet management, predictive maintenance of your fleet. So nowadays, every car, is reporting back data to the factory and they're going to send you notifications, your car needs service, etc. Driver monitoring, is also something like if you're sleepy and you fall asleep at the wheel, the car is going to stop because there's a camera monitoring you. That's also AI, right? And all the driving assistance systems we talked about. So there's a lot of this thing that is coming. And so there's the other, so as these get more and more accepted in the vehicle, I think over time, we will sort of have this evolutionary approach where eventually you expect the car to do so many things on its own, then for short distances, it's a self-driving car, right? So there's the other theory that we will come to the same point, maybe 20 years in the future, but in slow incremental developments. And that's the kind of development that we are usually underestimate, right? There's a thing that says we tend to overestimate some of these big changes, but we underestimate the cumulative impact of small changes like this, which over 20 years can get us to a point like smartphones did, right? Where you just expect the phone to be aware of certain things and you just use it. Just like that, the car will be this intelligent device that knows a lot of things about you and is connected and has apps. And as soon as you get in, it kind of knows where you want to go and it starts going, right? Maybe that we will slowly in small evolutionary steps get to that point. Okay. The other part that I promised to talk about a little bit on trends in robotics. This is going to be a little shorter section. I'm just going to highlight some of the trends that I have seen myself. The first is, of course, humanoid. That's like getting a big amount of news. I think there's a lot of hype in this. I think it's way too early to be talking about humanoid robots. But there was already a Goldman Sachs report that gave you a projection out to 2035 about like how many million units of these humanoid robots are going to be sold in the world, right? We are right here in this 2024, we're practically zero, okay? So these guys have they just worn a magic hat and come out with predictions, and they have like different cases, a bear case, a base case, a bull case, and some kind of blue sky case where we're going to be shipping 12 million units a year by 2035, right? So these are huge predictions. This is sort of like, everybody in their house has a little humanoid robot in the future doing these things. And the reason they're making these predictions is they're seeing some of these AI doing, and this is literally from the report that says end-to-end AI could potentially enable much faster human-robot interaction. So it's like a very high-level abstraction. They said, hey, we see technology, we see AI, computer vision, so we're going to project out 20 years and say everybody's going to have a robot. These kind of predictions are usually way too optimistic, to be even taken seriously. But this is just to tell you what's out there in terms of like what people are saying. Some of these companies like Figure is a company that raised $600 million or something in funding in the last year because some big people with a lot of money have decided maybe this is the time now for humanoid robots to come. So we've all, humanoid robots have been like in experimental phases for many years. Robot helpers, etc. All the companies have been trying to do something or the other. Some people have come to the conclusion that maybe now with AI we can do it. I don't know myself. I think we are way too early to be making this kind of prediction. But I can tell you there is from papers that have been published in the last year or so, the TR2 robot, which is the paper from Google, I think on their robotics research, about vision language models, where they actually co-fine-tune this language model with vision and robot trajectory data, okay? Robot trajectory data represented as tokens, which means represented in language format, right? And if you train the robot trajectory and what the computer vision is seeing and language, which is what language models are all about, you can actually get robots to do tasks like this, right? Move the banana to the sum of 1 plus 2, and it knows that, it interprets that, and it also knows in terms of trajectory what move means, like grasping, lifting, moving. All these things are also, it's been trained on these things so that or co-trained with language and trajectory data, which means that it can translate language to trajectory easily, just like language to vision or language to something else. So language to trajectory becomes easy. So you can give it high-level commands that it will actually execute without you having to then give one more level of lower-level commands. So this is the kind of thing that's made, these predictions of this future of humanoid robots possible, is because we're seeing this kind of thing was very difficult 2 years ago. Right now with language model and vision model and robot trajectory planning, this is actually possible now. So it seems like a big change. Maybe we'll see robots doing this kind of thing. So if you're working on robotics, read, you probably have come across this already. If you have not come across it, take a look at this paper. And the idea is just like language models, it can also generalize to novel objects and rudimentary reasoning. So, it has never, let's say it's never seen a banana, maybe it can still do that. Or it's never, nobody's asked it to do some kind of other reasoning, right? It can do that. So that's kind of the reason why this is becoming interesting. And as, if you're working on robotics, keep this in mind. People will expect your robot to be able to take high-level abstract human language human language as input, and they will also expect the robot to be able to do some amount of reasoning on its own, that you don't have to go and program it. You can just speak to it, right? That's going to become an expectation, I think, in the next year or two. So the other thing is, there's the other thing within like language models, there's a thing called chain of thought reasoning, right? Where you can actually, in the prompt, if you give it multiple steps, you can actually get the language model to give you a much better, much more consistent planning and output. And so here's the thing where the planning as a separate step, so you can see here, right, there's a plan is a separate step that has been actually in the robot has actually been trained using these language model and a planning step, and then the final execution in terms of the trajectory, right? And so by making this 3-step process as part of the training, the robot's actually able to handle a little more sophisticated commands. Like, for example, I think if you say things like, hey, I'm feeling thirsty, it's going to go find a drink for you and bring it to you. Something like that, right? So this is also something that we're going to see with vision, language, action models. This is called what is called like VLA models, vision, language, and action, because it's using vision, it's knowing language, it's connecting the two. If you say 7-Up, it knows what a 7-Up is, and it's going to go and find that. If you say bring it to me, it knows what that means, and it means it's going to go do that. All of this is because it's been trained on the actual plan step and the actual action step, both of these as part of the training using language models. So all of this planning and action are just simply tokens and simple language, right? And so you can put all of this together in a data and get it all trained, or fine-tuned using the same transformer model architecture, and it's going to follow these commands as though it's doing language thing. So that way it's very straightforward, but pretty remarkable that it works. This kind of thing, the accuracy, safety, highly unknown. There are people saying that, well, this is the kind of thing that we're going to have in self-driving cars. Just say, take me to X, and then it's going to plan out a route, plan out the trajectory, start driving, and it's going to also, when it comes across pedestrians, whatnot, it's going to know what you need to do because it has been trained on that kind of data. So that's all true. I think that may be where it's going. I've heard that Tesla has already got a fairly sophisticated end-to-end perception and planning in their FSD stack. So eventually this will come to automotive also, except that of course we will have to go through all the regulatory and all the questions we talked about, right? Pending all of that, but I think in terms of the technology, this is kind of what I'm expecting to see in self-driving also. So, so I think in terms of future directions, these are some of the things that I'm also seeing, that learning new skills will be coming from actually seeing humans or learning from videos of humans doing things rather than explicitly planning action type of thing. It's going to just look at human doing it and repeat that. And we see that from these soccer playing robots and things like that. They're beginning to learn by just things like reinforcement learning from humans and learning from each other and improving over time. We see that. Secondly, running on edge hardware means you have to have much, much lighter weight models. You don't have big GPUs on lightweight robots. So we're going to have to figure out how to make these models lightweight enough that they can run inference on the edge, low latency. I think that will happen. Many of these models, you lose some amount of accuracy, but you can actually get reasonably good performance when you run it on edge devices, low power devices. And that's still a research direction. I think that's something that's going to continue. And finally, the end-to-end AI for autonomous vehicles. There's a couple of startups that are doing that too. They're saying that we're going to train the self-driving car, but not like a perception module and a planning module and a control module, but this end-to-end AI that is just going to learn from, million miles of human driving, and it's going to learn from that. And this big neural network that you input LiDAR cameras, or other sensor data, and it's going to take all that data, and in real time, it's going to plan your trajectory and drive the car, right? So that's kind of the end-to-end AI of autonomous vehicles. There is research, it's promising. It will definitely take a long time, but that's kind of the direction in which it's going. All right, I think that's it from me. So any other questions? Cool, thank you very much. I'll be hanging around here if anybody want to come up and ask me questions. I'm available, so please feel free to do that. Yeah. So questions about digital chassis. So companies like NVIDIA and Qualcomm are making the chips, right? So for them, that's how their path to commercialization is, through selling these chips. I personally do not have a whole lot of idea about digital chassis, but I suspect what it is an application that demonstrates how these chips are going to be used by their customers. Mostly in the automotive industry, there is the OEM, which is the car maker, subcontracts many of the pieces to what's called these tier 1 vendors. And there are big companies like Bosch and Denso are two of them. And they in turn go and find the appropriate chips for the chassis that they are building. So usually these tier 1 vendors are responsible for these kind of like chassis systems and, driving assistance systems. And they are the ones making the decisions. And usually they also want to have multiple chip vendors to be able to plug and play, because otherwise it doesn't give them competitive pricing if they are stuck to one vendor's thing. So that's So I don't know much about the digital chassis. I'm not that familiar myself, but I suspect that it is more of a reference design made by these guys, so that it makes it easier for the tier 1 suppliers to then design their own custom chassis for the OEMs. This whole thing is also being disrupted with the electric vehicles. Chassis are simpler, and highly instrumented, and a lot of data being going from different parts of the chassis to one central gateway computer. And this is where I think like the NVIDIAs and Qualcomms want to have that gateway or the main processor where every single sensor input is coming there, and in real time it's making all the decisions. So with that kind of thing, I suppose, in the future you can have, if it starts raining, you automatically roll up the windows, change your lights, change your driving behavior. All of these can happen in very quickly because your digital chassis is already aware of all these things. So, that part I know, but where does it fit in the stack of autonomous driving? Not really. I mean, it's something that will happen. It's for enabling what's called the software-defined vehicle. So a smart vehicle that can configure automatically. It doesn't have to be self-driving. Self-driving is different. The self-driving decisions are also kind of related because your digital chassis will enable all these things, but they're unrelated. They just will happen at the same time. People also think about, electrification and autonomous as one thing. It's not one thing. You can have autonomy on a internal combustion engine and a petrol car also, right? So not related to each other, but they're happening at the same time. A driverless and it's a converging of a driverless car and a software-defined smart car. Yeah, I think so. I think the smart car is making faster progress right now. So we're going to have these electric cars, especially in China, where they've been, Chinese companies have been and Taiwanese have been making like electronics, computers, motherboards, highly efficient, and they have like mastered the supply chain, and the manufacturing of this is really good, and battery packs and those things, right? Turns out the electric car is pretty similar. It just, like with wheels and a chassis, and I think they're doing a really good job. Like low-cost Chinese electric vehicles are now present all over the world. I don't know if they're here yet. I'm not sure, but there's some parts of the world they're actually pretty popular and they're cheap. And so that is, those are all going to be smart, as in the sense that all the components, entire chassis is going to be controlled by software, and so they'll have the chips to process all these things. But they may not really be. I think self-driving will come later. I think having everything smart and configurable will be the first thing. There's also, there's been some funny things like some features can be turned on or off. Like, for example, automatic. So there's this heated seats, for example, in the colder countries, right? You have the heated seats as a feature in the car, but you need to pay a subscription, and if your subscription runs out, then you stop getting that feature because they're going to turn off the feature. That's the kind of thing they can do with the smart chassis, right? Which is kind of like, sometimes it's funny as a customer, you're like, oh, I forgot to pay my bill, so my car won't do this thing or something. It's kind of, but that's what the companies want. They see every little feature as a thing that they can turn on and off as a service, and on a monthly recurring so they sell you a car for pretty cheap, but they make a lot of money on all these like add-on services. And maybe your car is, you're driving by McDonald's and your car will stop there automatically or something. I don't know. So maybe lots of other smart features are going to come in, right? When you combine the smart car and the self-driving car, and you get an ad for things as you're going along. Your GPS knows where you are. You're going to see ads for what is like around you, and suddenly the thing knows that you're feeling hungry. It's going to pull into the shop and for food, or what, all those kinds of features are coming. And that's the focus for all these digital chassis, I think, like trying to figure out how to coordinate the whole driving experience in a unified way, which is then a platform for advertising, for commerce, e-commerce, and all that other things that's going to come on top of that. All right? Yeah.
So it's, the front page of today's business is new regulation of AI being used for copyright. So New York Times is going after OpenAI. Used a lot of copyright in credits. How much of this would affect? How much? So, for example, maps, we have to just writing, stuff.
So good question. Question is about copyrights in the training data that is gonna affect the users of the AI that it was trained on. I think this will get settled somewhere through the court system is my prediction. And eventually we will figure out where, how, and all of this is gonna land and who pays for what and how these things are commercialized. I don't think it's nobody's treating this as a fundamental issue that's gonna be that's gonna stop the business. I think everybody is feeling like, well, we'll figure out some way to smooth it out. And specifically for automotive, nobody's talking about it because I think all the training data is for all these companies, it's their own training data because they have their own sensors, they're driving their own miles, collecting the data and learning from it.
But somewhere there may be the maps.
Yeah, that's true. The maps are also usually they're licensed maps provided by third-party countries, right? And so third-party companies, and so those are also well, I think, licensed. And the satellites or whatever, right? They're also known licenses. Unlike the sort of the language models with this like training on internet data, that's when it becomes a little confusing about did you learn something from somebody's proprietary data and we don't know. That has not really come up in self-driving. Of course, if you start talking to your car in a language using language, then that question could come up. I think we will have to solve it as we go along. That's probably true. Yeah. Europe will has its own things. Yeah.
What are your views on your vision design? What are your views on your vision design versus LiDAR and the vision design? Yeah.
So most people other than Tesla are very skeptical that pure vision will succeed because pure vision is, it has the problems that under bad lighting conditions, you have no other sensors to figure out anything else. And you can do no better than a human. Now, if you're trying to aim for human accuracy, maybe you can, but everybody in the industry feels that you add a radar, which is not that expensive. You have an additional mode of input, which is, much more, it reduces your failure rate that much more because it just gives you an additional data point that when vision fails, you have that. So I think, to me, radar is cheap enough that I think all cars will include multimodal, that is, vision plus something, most likely radar, maybe LiDAR also, to make a, much more robust driving assistance or full self-driving system. Camera alone, is it possible? Yes, maybe 99% of the time, yes. But I don't think it's compelling enough in the sense that doesn't make it that much cheaper to remove that radar that it makes that it's really that important. I know Tesla has said they're the only ones that actually say that this is the way we're gonna go. They have a valid argument, but my own feeling is over time they might reconsider that decision and maybe come back to a camera plus other sensors. Yeah. Cool. All right. Anything else? Well, thank you very much. It's been a pleasure. I appreciate all of you coming, and thank you.